You already know what a T-Rex looks like. You've seen it in every museum you've ever visited. You've seen it on screen. If you grew up watching Jurassic Park, you've seen it there too. You think you understand it. Massive. Slow. A scavenger, some scientists said. An animal so large it could barely support its own weight, lumbering through a prehistoric world that no longer exists. That image is exactly what makes it so misunderstood. Because here is what most people are never told. Tyrannosaurus rex was not a slow, dim-witted giant coasting on size alone. It was one of the most sophisticated predatory machines evolution has ever produced, operating a sensory system that surpassed most living apex predators, capable of generating bite forces that no land animal, before or since, has matched, and moving through a social and ecological reality so complex that paleontologists are still revising everything they thought they knew. The image you carry in your head of a T-Rex, thundering, predictable, almost cartoonish, is one of the most aggressively simplified impressions in the entire history of how we think about predators. What it actually was is something evolution spent tens of millions of years building into a specific and terrible shape. And what evolution built when it built Tyrannosaurus rex was something that should command a level of fear we have almost entirely failed to give it. To understand T-Rex, you first have to understand where it lived and what living there demanded. The late Cretaceous of what is now North America, 68 to 66 million years ago, was not a stable environment. It was a continent in ecological upheaval. Sea levels were dropping, forests were restructuring. The prey species T-Rex depended on, Triceratops, Edmontosaurus, Ankylosaurus, were themselves large, armored, and capable of catastrophic defensive force. This was not an environment that rewarded passivity. Every calorie required effort. Every kill carried genuine risk. In this environment, T-Rex did not evolve to be slow. It evolved to be efficient. And the toolkit it developed for efficiency starts with the body. Tyrannosaurus rex stood approximately 4 meters at the hip. It measured between 12 and 13 meters from nose to tail. It weighed, in the largest confirmed specimens, somewhere between 8,000 and 14,000 kilograms. By any measure, that sounds like a problem for locomotion. It was not. Biomechanical modeling published in the journal Peer estimated T-Rex's preferred walking speed at approximately 4.6 to 8 kilometers per hour, a brisk, energy-efficient pace that a human would struggle to sustain over distance. More recent work on leg musculature suggests brief bursts of considerably higher speed were achievable, though the debate on this remains active. What is not debated is this. T-Rex was not stumbling under its own weight. Its skeletal architecture, hollow bones, pneumatized to reduce mass while maintaining structural integrity, was the same engineering solution used by modern birds. It was built light where it could afford to be, and dense where it could not. And then, there were the jaws. The bite force of Tyrannosaurus rex has been studied, modeled, and revised more times than perhaps any other measurement in paleontology. The current consensus, based on computer modeling of skull geometry and jaw musculature, places peak bite force at approximately 35,000 to 57,000 newtons. To place that in context, a saltwater crocodile, the hardest biting living animal, produces approximately 16,000 to 18,000 newtons. A spotted hyena, whose bone-crushing bite is among the most powerful in modern mammal biology, produces roughly 4,500. T-Rex's bite was not in the same category as these animals. It was in a different category entirely. The teeth reinforced this, not blade-like as in most theropods, designed to slice. T-Rex teeth were conical, thick, banana-shaped in cross-section, designed not to cut flesh, but to crush through it, through bone, and emerge intact on the other side. Fossil evidence confirms this was not theoretical. Healed bite marks on T-Rex prey bones, Triceratops frill fragments, Edmontosaurus vertebrae show punctures where teeth drove through solid bone, released and repeated. The animal wasn't simply biting. It was processing its prey the way industrial equipment processes material. One specimen of Edmontosaurus recovered from South Dakota showed bite marks penetrating completely through the ilium, the hip bone, with bone regrowth around the wounds, indicating the animal survived at least one such attack. What the T-Rex did to that animal, and the animal still lived, tells you more about the force involved than any model. No single discovery communicates what T-Rex actually was, beneath every assumption we carried into the 20th century. Better than what happened in the Hell Creek Formation of Montana, beginning in the 1990s, and continuing for decades after. Paleontologist Jack Horner and his team began finding something that changed the framework. T-Rex juveniles, subadults, animals at different growth stages. What the growth data revealed was this: Tyrannosaurus rex went through one of the most dramatic ontogenetic transformations documented in any predator. Juveniles were lean, long-legged, and fast, built for active pursuit, with proportionally longer limbs and blade-like teeth suited for slicing soft tissue. Adults were massive, heavily muscled, bone-crushing machines with the proportionally small arms and enormous skull that define the animal in every image. These were not simply big and small versions of the same animal. They occupied different ecological roles. Juveniles and adults of the same species were functionally different predators, which means T-Rex, across its lifespan, was not one predator. It was two, in sequence. A pursuit predator that transformed over approximately 20 years of rapid growth into an ambush-capable bone-processing apex predator with no ecological equivalent in its environment. The growth rate required to achieve this was extraordinary. Studies of bone histology, growth rings preserved in fossil bone the way rings form in trees, indicate T-Rex grew at peak rates of approximately 2 kilograms per day during adolescent growth spurts. More than 2 kilograms of body mass added every single day, for years. To sustain that growth, the animal needed to eat constantly. And to eat constantly in the Hell Creek ecosystem, it needed to be far more capable than the lumbering scavenger hypothesis suggested. The scavenger debate is worth addressing directly because it defined how an entire generation understood this animal. Jack Horner argued for years that T-Rex was primarily a scavenger, that its small arms, its forward-facing eyes, and its apparent bulk made active hunting implausible. The argument received significant popular attention. It was wrong. The forward-facing eyes that Horner cited as evidence of scavenging are now understood as evidence of the opposite. Binocular overlap in T-Rex, the degree to which both eyes saw the same field, was approximately 55 degrees. For reference, a hawk has approximately 50 degrees of binocular overlap. The animal had depth perception refined for tracking moving prey at distance. Its olfactory bulbs, preserved in endocasts of the brain case, were proportionally enormous, among the largest, relative to brain size, of any theropod. A scavenger needs to smell carrion from distance. A pursuit predator needs to smell living prey through cover, in motion. T-Rex had both capacities at extraordinary resolution. And the arms. The arms that seem vestigial, that seem useless, that became the basis of 1,000 jokes. Biomechanical analysis of the bicep attachment points indicates each arm could curl approximately 180 kilograms. They were not vestigial. They were short and enormously powerful, and positioned exactly where a predator would need them in close contact with struggling prey. The social behavior of T. rex is the frontier that current research has barely begun to map. For most of the 20th century, T. rex was assumed to be solitary. One animal, one territory. No social architecture worth documenting. That assumption began to erode in 2014, when a site in the Grand Staircase Escalante National Monument in Utah yielded something unexpected: multiple T. rex individuals in the same bone bed. Different ages, different sizes, together. The interpretation remains contested. Bone beds can form through flood aggregation, bodies washing into the same location with no behavioral implication. But the Utah site's geology suggested something different. The animals appeared to have died in proximity, as a group. Subsequent analysis of trackway evidence from other sites has added weight to what some researchers now cautiously describe as possible gregarious behavior, the idea that T. rex, at least occasionally, moved in coordinated groups. If that interpretation holds, the implications restructure everything. A single T. rex was already the apex predator of its ecosystem, with no qualification. A coordinated group of T. rex individuals, hunting with the same coordinated strategy that makes wolves, lions, and orca among the most effective predators alive, would have represented something the Cretaceous had never seen. The prey animals of the Hell Creek Formation were large. Triceratops weighed between 6,000 and 12,000 kilograms, fully armored, with horns capable of driving through bone. A lone T. rex taking a healthy adult Triceratops carried real risk of catastrophic injury. A coordinated group changed the calculus entirely. And here is the detail that almost never enters any account of this animal. T. rex may have had lips. In 2023, a study published in Science presented evidence, based on comparative anatomy with living archosaurs and analysis of tooth wear patterns, that T. rex and other large theropods likely had non-retractile lips covering their teeth when the mouth was closed, not the permanently exposed dentition of every film depiction. Lips, like a monitor lizard. This matters not because lips are frightening. It matters because of what it means for everything else we assumed. If the teeth were covered, the skull was not the skull of an animal permanently displaying its weapons. It was the skull of an animal that concealed them, an animal that could approach, observe, position itself without the visual signal of exposed teeth advertising its presence from a distance. The predator we thought we understood was advertising itself constantly. The predator the evidence now suggests was not. Tyrannosaurus rex survived for approximately 2.5 million years, longer than modern humans have existed as a species. In that time, it occupied the apex of the most diverse and ecologically complex terrestrial ecosystem of the Mesozoic. It adapted. It changed. It refined. The last generation of T. rex alive on Earth, the animals that watched the skies in the final days before the Chicxulub impactor ended everything, were the most evolved version of a lineage that had been refining itself for millions of years. They did not go gently. The Chicxulub impact released energy equivalent to approximately 1 billion times that of the Hiroshima bomb. The immediate shockwave, the global firestorm, the years of impact winter that followed. In those conditions, even the most sophisticated predator in Earth's history could not adapt fast enough. But in the millions of years before that moment, T. rex had done exactly what evolution demanded of it. It had become something that nothing in its ecosystem could reliably stop. And here is the hardest thing to hold in your mind, all at once. T-Rex was not a monster. It was not malevolent. It was not, by any standard that applies to the Cretaceous, cruel. It was exactly what tens of millions of years of evolution under intense predatory competition produces. Its intelligence was real. Its sensory architecture was extraordinary. Its bite was unmatched in the history of land predators. Its capacity for growth, the transformation from pursuit predator to bone-crushing apex machine, is one of the most dramatic biological trajectories ever documented. We looked at it, and we made it slow. We made it a scavenger. We gave it a roar borrowed from other animals and a posture that fossil evidence has since corrected. We turned it into a theme park attraction, and in doing so, convinced an entire civilization that one of the most refined predatory organisms in Earth's history was something we had already figured out. The Hell Creek Formation is still being excavated. New specimens are still being found. Every decade, the picture changes, and the animal keeps being more than we thought it was.